Hello friends, today I'm going to discuss something about that Wi-Fi 6. This is a new, like the technology which has come up in the market. We've been talking about like 802.11 something A, B, G, N, and some other standards also been there. They come out with the name called Wi-Fi 6 now. They would like to change the name because they don't want to continue anything with that 802.11 because it's quite harder. So what they tried that they tried to change the names as a Wi-Fi 6 for that. And in this small, in like the presentation, I'm going to discuss something about the Wi-Fi 6. What is in this and why we require this Wi-Fi 6? How do we compare that with the earlier versions? What all the advantages are there? How much speed we can able to achieve with this? What are the devices we can connect with this Wi-Fi 6 standard? And what are the like the routers which will be supporting that Wi-Fi 6? What is the standard as first of all? And how do I upgrade my PC for that for Wi-Fi 6 and the routers and other devices as well like that. So it's a very small presentation. There is no demonstration on this. It's only just like the slides. I'm just going to run it over with that. Okay, let's start the slide. What is Wi-Fi? The term Wi-Fi was created by the non-profit Wi-Fi Alliance, and it refers to a group of wireless networking protocols that are based on the IEEE 802.11 network standard. This we know already very well because we've been using in the daily day-to-day life. Because the primary connection in the corporate offices nowadays it's become Wi-Fi connections only. When we are having the meeting or something like Skype or some other meetings if we have through the telepresence or something like that, we will go with the wired connection or something, but else we'll be normally continuing with the Wi-Fi only. So Wi-Fi has been around since the late 90s, but has improved dramatically in the last decade. This is the standard and the frequency and the maximum link rate and year when it has been introduced. Now they just given that. It's okay for if you're going for some other interview or something like that, you can just say this. We can just start with this one like the 2009. It is 11N. This was normally everybody else is actually normally we are implementing this 11N only. Nowadays it's been going on. And from the AC, that is called as a Wi-Fi 5. You see that there is a Wi-Fi 4, and this is a Wi-Fi 5, and this is a Wi-Fi 6. In the Wi-Fi 6, the standard has become like 802.11ax actually. This is a frequency rate, and maximum link rate is this much. So near about 1 GB something like that it is coming. But they're saying that 10 GB is possible. Maximum link rate or something. Let's see some other slides as well on this one. So that'll be giving us a much good idea about that. But this is like when it has been introduced, it's been introduced on 19. Whether it is available for the current market, yes, it has been available. Wi-Fi 6 is available for us. So let's go to the next slide. This is about how the evolution happened. New naming standard, you just see that. The naming standard, you can just see 11B is a Wi-Fi 1, 11A is a Wi-Fi 2, 11G is Wi-Fi 3, 11N is a Wi-Fi 4, just we seen. AC is a Wi-Fi 5, AX is a Wi-Fi 6. So what is the speed it's going to give that? That is what more important because we are just looking for heavy speed on the Wi-Fi connections itself. We are not getting much speed as such because if there is an interactive communication happens on that, Wi-Fi doesn't work properly. Moreover, the people will be try downloading some of the things on the office itself. From the SharePoint, we download something like that. From the YouTube, we'll be seeing that, and the heavy files which has been sending by the the customers and all like that. We just go and download it from the Google Drive or from internet sites and other things. So that makes sense here. So this is 11A is being introduced on 1999, which is providing the 54 Mbps for us. 11B was giving 11 Mbps. 11G is giving on 54 Mbps, the same one, like 11 and like 11A is something like that. 11N was giving the 600 Mbps, but we don't get the 600, but we just say that it is under the proper, like the environment. if there is no much interferences and things are there, we'll be getting around 600 MB. The 11AC is about the 2013. They say that it has been available on 1.3. Now there's a blockbuster saying like that AX is providing the 10 Gbps connection for us. So this is about the standards and other things like. So how things are getting implemented, all devices are going to get supported on this, and those are all things we'll be seeing it in the next coming up slides. This is about the, the tabular column, like comparisons of the speed and frequency band and the standards as well. So now from now on, like we will be seeing something on, people will be saying only the Wi-Fi 6, Wi-Fi 5, like that. We don't see anymore like the 802.11 A, C, G, B, not required. Let me go to the next slide. To make the difference between the, one second, let me make it down this. Okay. To make the differences between the each generation more obvious, the Wi-Fi Alliance recently adopted a more traditional naming convention, dropping the 802.xx designation for a simplified numerical suffix. This is simpler labeling convention. Wi-Fi 6 versus 802.11ax makes it easier to know what generation of the technology is being utilized and to determine the compatibility with the devices that support the version. Then how it has been different, why it has been different, what are the different things which we are going to discuss about that. Means like from 5 to 6, what are the differences are there? Substantial upgrade over the previous generations, though the differences may not seem immediately obvious for the average user. These changes might not dramatically change the way we use the wireless routers or wireless networking, but instead consist of many incremental improvements to the stack after the substantial upgrade. Not understanding what is it. Anyway, the first big change is that Wi-Fi 6 allows a potentially faster connection speeds. That is what the most important thing. Okay, let's go to the next one. Faster speeds in the sense what? Faster Wi-Fi means a better upload and download speeds or the throughput due to the increased bandwidth afforded by the Wi-Fi 6. This is becoming increasingly important for the file sizes to continue increase along with the higher data demands of streaming high quality video and communication, heavy online gaming. This is also very important, but in our office there is nothing like we can't do any gaming at all. Playing a multiplayer game while streaming the Twitch requires a large amount of bandwidth and reliable and stable connection. Maybe like if you're going to a kind of a cyber cafe and all like that, maybe the people will be deploying this Wi-Fi 6 to have the people to get enjoying all those things. So how much faster is Wi-Fi 6? 9.6 Gbps is the maximum throughput of Wi-Fi 6 across multiple channels. Speeds can be faster when it compared to the Wi-Fi 5. This is some supporting something like 9.6 Gbps. It's supporting very faster, and it is 75% of the less latency. This is that it's giving the less latency, and the Wi-Fi 6 brings the wired and wireless signals closer to the parity. Much technical thing. You can just think about that. Only 75% of the latency is getting reduced. Like latency is the bigger thing. When you try to see a video or something like that, it should not be buffering. It will be boring for you. So that is getting removed when you try implementing the Wi-Fi 6. We'll be seeing one by one with some explanations on this. 9.6 Gbps. In contrast to Wi-Fi 5 offers the maximum of 3.5 Gbps. These are theoretical maximums for, however, in real world situations, local network may not reach that top speed. Because the maximum is shared across multiple devices with the Wi-Fi 6 can enjoy significantly faster speeds even if they don't reach the maximum potential. See, that is a laboratory condition they're talking about, that we will be having around 9.6 Gbps or something, but it may not be able to reachable, but it will be more than that, of around 3.56 or something like that will be reaching. Speeds can be faster when compared to 5. This assumes you are using a Wi-Fi router with a single device. 6 can achieve higher data transfer speeds through the variety of the techniques, starting with the more efficient data encoding and intelligent use of the wireless spectrum made possible by the more powerful processors. Okay, anyway, they just making it saying that we just need to agree that 75% of the less latency. This is very important point. 75% of the less latency It achieves handling the large amount of the data and network traffic more efficiently. For gamers, this means a faster game downloads, better upload speeds, with a streaming gameplay, and more reliable media multitasking. Brings wired and wireless signals closer to the parity. This potentially frees more users from constraints of being hardwired to the modem. Many gamers or content creators still connect directly to the routers or network switches via Ethernet cable instead of taking the advantage of the flexibility that wireless networking provides. 6 helps further bridge the gap between the wired and wireless connectivity. So speed is there, latency is lesser. We can try for that. What makes it is faster? What are the things we just need to discuss about that? Orthogonal frequency division multiple access, overlapping basic service sets, beamforming. There are three major things they're discussing in the Wi-Fi 6, which is the improvement which has been made on that. Wi-Fi 6 communicates better with the multiple devices that need data simultaneously and more efficiently prioritizes the traffic across those devices by using these three set of enhancements. From smartphones to the tablets to the televisions to the IoT devices like thermostats and doorbells, just about everything we can connect to the wireless router. That is what happening. That is what IoT devices are making the things to go slower. Normally we use mobile phones, cell phones, like watching some kind of Facebook status or WhatsApp status. That much only we used to do that, but nowadays it's been all IoT devices are getting connected. So three technologies has been introduced on this. One is a OFDMA, that is orthogonal frequency division multiple access, overlapping the basic service sets, beamforming. We'll see one by one on this. Much technical thing, but still just see that. OFDMA is one of the ways that has been achieved. It works by subdividing the channels to the sub carriers and allowing for transmission to multiple endpoints at the same time. 6 router can send Wi-Fi 6 router can send different signals in the same transmission window. This results a single transmission from router being able to communicate with multiple devices instead of each device having to wait its turn as the router serves up the data across. It means like it's completely parallel. Okay, let's see next slide. Overlapping basic service sets is another Wi-Fi 6 feature that can help to improve the network congestion. With the older version of the Wi-Fi, devices try to connect to the network used listen before talk process. Still we are using them, which meant they had to listen for any noise on a channel before transmitting. OBSS enables the access point to use a color in order to uniquely identify the network. If other network is detected on the channel, but it is not the same color of the local network, devices can ignore and it can continue transmission. This can help to increase the reliability and improve latency. You see that? OBSS, it is finding out that who is actually talking to me. The PC is talking, PC is having a different color. And there is a laptop is talking to that. Smartphone is talking to that. Some other devices like it comes up. So everything has got its own color. It is serving its own bandwidth accordingly. Whichever the device is looking for a more bandwidth or something other, it's giving that. So this is kind of enhancement we can look for, and we can think of this. The next is a beamforming. Beamforming look like much more, very advanced thing. It's another technology. Wi-Fi 6 improves its in order to achieve the higher speeds. Instead of broadcasting the data in all directions, the router detects where the device is requesting the data is located, and it transmits more localized data stream in that direction. Beamforming is not new to the Wi-Fi 6, but its efficacy has been improved in this generation. You see that? The earlier one we were using like this. It's completely circling. But here it is a beamforming. Where the guy is sitting there it will be sending it. It finds out the location of the person who is in the room, and it has been sending it to that device only. Pinpointly, the beam will be aimed towards the destination only. It's not given for everything. Like it doesn't spread across the entire room or something. So these are all the three technologies. What are the technologies? Orthogonal frequency division multiple access, overlapping basic service sets, finding out the colors, beamforming, finding out the where the device is originally located. There it has been sending that, the traffic to that. And it has got some other benefits as well. Network benefits beyond the speed. More than speed, what else we get? Speed is probably the most important thing to average user, especially for the gamers. But there is more to a wireless network. Wi-Fi 6 also promises improvements in security. WPA3 until WPA2 we have been using that in 802.11n network or AC network, something like that. We've been using that. Battery life and target wake up time is also being there. That is something, two things which we talk about. WPA3 is a Wi-Fi protected access, is a common Wi-Fi security protocol that uses a password for encryption. Anytime a password is required to sign into the Wi-Fi network, the WPA is in action. PA2 has been standard for a long time, but that is changing with the Wi-Fi 6. One of the biggest improvements is that implementation of the increased password security via Dragonfly key exchange system. Something they bring it something new. Dragonfly key exchange system, which is also called a simultaneous authentication of the equals. This authentication method helps the make passwords harder to crack by using a most sophisticated method of establishing the handshake between the in the Wi-Fi network. We've been using some kind of cracking things and all that. Whenever the initiation takes, means the person try to log into that first time, or he connects, disconnects and connects again. So he has to send the password to log into that. At the time we can hack into that and we can get the password for that. But that is more handshake is been happening. This added to the layer of security coupled with a stronger encryption means Wi-Fi will never have more robust security options than ever. Extra layer of security is a great example of how Wi-Fi 6 changes the things for the better without negatively impacting the user experience. Okay, these are all we just need to try that and we can find that. And the next, battery life. Battery life, because when we connecting the device to the Wi-Fi router, in the sense when we are not using that, we'll just switch off that Wi-Fi. So to save our battery, because keep on communicating with the device, keep on communicating with the router, our device loses the battery normally. So this another forward-facing development incorporated to the Wi-Fi 6 is target wake-up time has the ability to potentially increase the battery life on some devices. This technology allows more efficient communication between your router and the device regarding when to sleep or wake up. Means if you have a Wi-Fi router, if you're not using, nobody is using, in the sense that Wi-Fi router will go and sleep. That is normally been there. But devices has also been getting the sleep on this by effectively communicating with the device Wi-Fi radio and only activating it when it needs to be awake. Your device will spend less time and energy searching for a wireless signal. This can enhance a better life. You see that? By effectively communicating with the device Wi-Fi radio and only activating when it needs to be awake, your device will spend less time and energy searching for the wireless connection. Whenever it is trying to establish the connection, there will be the more power will be used for to connect to it, because it has to send some kind of handshake and other things, encrypted traffic which goes on, and suddenly increases, then it will go normally like that. So that can be avoided, and battery life can be increased, and it can save a lot of battery because of that awake technology which is being introduced on this. Saying that, let's see. In addition to the Wi-Fi 6, another new technology has arrived recently. There is a Wi-Fi 6E, that is an enhanced. Wi-Fi devices had previously seen restricted using only the 2.4 gigahertz and the 5 gig frequencies, but now that is recently changed. 6E enabled devices can utilize 6 gig frequency band, which provides a 1200 megahertz of bandwidth, making it ideal for delivering the high amount of data shorter distances. This can help alleviate traffic congestion and the interference for supported devices. Think of Wi-Fi 6E as a new wider lane being added to the previously two-lane Wi-Fi freeway with all the advantages of the Wi-Fi 6 included. And not every other device will be supporting this Wi-Fi 6E. So be sure to check the hardware you are considering supports the Wi-Fi 6E when upgrading. That is also there. We just need to go through the documentations of the device which we are purchasing, either router, mobile phones, or laptops, like tablets and other things. Let's go to the next. What do I need to make Wi-Fi 6 to work for my network? Here is what you should consider when making the switch to the Wi-Fi 6. Does your router support Wi-Fi 6? You just ask these questions. Do your devices support Wi-Fi 6? Does your PC support Wi-Fi 6? We'll see that first. The most important upgrade you will need to take the advantage is that new protocol is a Wi-Fi 6 capable router. Most manufacturers offer routers with the Wi-Fi 6 capability already. So there are plenty of options to choose from, no problems. So we have router ready. Next, do your device support the Wi-Fi 6? You also need devices to have the ability to use the Wi-Fi 6. Though Wi-Fi 6 is backward compatible with the older 11AC, that is a Wi-Fi 5, you will need a Wi-Fi 6 capable device to take advantage of everything we listed here. As Wi-Fi 6 increasingly becoming the standard over the next few years, newer devices will start incorporating the technology and it will become more new normal for that. Means first we just need to check whether our devices are supporting. Does your PC support Wi-Fi 6? If you have the latest generation of the Intel CPU and compatible motherboard, many of the pieces required for the Wi-Fi 6 to function is already included. Implementation of the Intel integrated connectivity CNBI means much of the technology that powers the Wi-Fi 6 is already available on your PC. We just need to check whether Ryzen processor is going to support that, AMD supporting that. Just need to check all. This is Intel is supporting that. It's having the Wi-Fi 6 function, the latest one maybe. And so we need to ask all the questions first of all, like whether we are equipped to go for Wi-Fi 6 or not. Okay. Next. Is it the time to upgrade your Wi-Fi? Wi-Fi 6 and Wi-Fi 6E will have more dramatic impact on the way we interact with our wireless devices. First point. Second, between the faster speeds, better traffic prioritization, and added security, Wi-Fi 6 is a significant step forward in the wireless network technology. Whether you are gaming, working, or just streaming video, upgrading to Wi-Fi 6 will be worth considering. So you can go for Wi-Fi 6 because all the devices which are going to come up in the market is going to get support on this. What could be the price range? We just need to check that. Until Wi-Fi 5, we've been using all these things. We are just happy with it because what all the technology is there, we're just happy with it. But now it is coming up with the 6 and 6E in the sense we may have to go for every other upgrades also as well. OS need to support, hardware need to support, tablets need to support. Which Android version is going to support that 6 now? Just need to work on this all. So this is about a small presentation which I made it for 6E, just an introduction. You can just take that. So Wi-Fi 6 has been already there. We are looking for to go for a considering about the getting upgrades on this. Okay, so that's all. It's a very small like presentation because I come through a lot of like Wi-Fi 6 technology when I was doing something on the Aruba, because Aruba is nothing but a wireless mobility express and other things they are having it, and the switches also start supporting all the integrations of the Wi-Fi modules and other things. So we just need to have some idea about what is Wi-Fi 6 which came up on this markets. So as usual, just watch this video on YouTube. I'll be sending on this, and you can recommend this video to your friends, colleagues, and relatives and other people. And like if you have any questions on this one, they can just reach to me on call or on the WhatsApp on the same number, which has been on your screen, and you can send an email on this stuckrod@gmail.com. Thank you very much for watching this video. Please put a comment on that, whatever you like it or don't like it, somewhere like that. I expect your comments on this. Thank you very much. Bye.